Find the restriction for sine theta plus tan theta over 1 plus cos theta. When we're looking for restrictions on trig identities, we need to consider each individual trig function and the entire trig function as a whole as an expression. In other words, consider the denominator. Let's look at them individually first. Sine theta has no restrictions. If you think of the sine wave, there's no asymptotes, there's no values of theta that would restrict it. Tan theta has a restriction. To find the restriction, we want to look at sine theta over cos theta, and our denominator cannot equal 0, so cos theta cannot equal 0. Where does that occur? Well, cos theta remembers the x values, so the x values at 0 are at pi by 2 and 3 pi by 2. If you remember on the tangent graph, that is also where your asymptotes are. So we can combine, rather than writing pi by 2 and 3 pi by 2, it's pi by 2 plus the distance of pi n plus the distance of pi n, and so on. Cos theta individually does not have a restriction. Again, just like the sine wave, it's just a regular cosine wave. Let's look at the entire fraction now. The denominator cannot equal 0. So if we look at that, 1 plus cos theta cannot equal 0. Isolate cos theta by moving that 1 to the other side, so cos theta cannot equal negative 1. We can find that on our unit circle as well. Cos theta cannot equal negative 1 at pi, not at 0 and 2 pi, but at pi. So theta cannot equal pi plus the distance of 2 pi n, 1 revolution. So if we want to look at combining these, this is already combined when we look at the pi by 2 and 3 pi by 2. Then we have this location. We can't combine this further as this is not where one of the restrictions is. So we have to state the NPVs as two separate equations right here.